Okay, well, I put together a thing here just recently, back in July. ST Microelectronics released a package that plugs into the Arduino environment and provides their HAL and the CMSIS, which is the ARM stuff, plus the registers. And one of the things is, be forewarned here, this is leading edge / bleeding edge technology. It's just been released a few months ago, and so I mean, there are going to be bugs, so don't panic if you find you have a problem. Okay, first of all, I'm going to talk about what I call entry level, and then given time we'll go into intermediate level and potentially talk about doing a real environment later. Primarily what we're talking about here is in the design complexity versus development effort. If you have an Arduino where you have a sketch, it's real easy. If you don't have a sketch, it gets pretty hard. Now, if you talk about a real environment, an industrial type one that's like Atomic 2 Studio, that's clearly a lot more effort to learn and get familiar with than an Arduino environment, but it carries you forward much better. Okay, a little history on the Arduino STM32. Back in the 2008 time frame, STM came up with their firmware upgrade package. What this is a package that with the USB interface can allow a part to update itself. Then in the 2009 time frame, Leaf Labs came out with their Maple board, and then subsequently with their Maple Mini. And around in 2013, the Chinese came out with their blue and red pill boards that are pretty much the equivalent. In 2014, Roger Clark came out with his YouTube on how to do that board in the Arduino environment. And in 2015, he started a web wiki on that, which is still active. And then in July of this year, ST Micro decided that they would start supporting that and came out with a board on that, or a package on that. Here's the link to download that, and I'll get into how to do that later. And then there's also this on how to put a new core in. It turns out to be a pretty much of a challenge to put a new core in. I wouldn't try that on a bet. Let's look at what we're talking about in terms of entry devices. In the AVR arena, you've got the Arduino Pro Mini and the Arduino Uno R3. The equivalent, so to speak, is the so-called blue pill and the Clio boards.
Can I ask a question just real
Yeah.
quick? On that 103 now, are you saying, does that have a separate device as far as if you want to download
No.
USB? No. Oh, it has internal, it handles
It
USB?
handles USB by
okay.
itself.
Okay.
And in fact, you can program it if you want to do virtual comm using USB.
Okay, because a number of their devices, they seem like they wouldn't let you talk USB directly, like in fact below they're using a STLink in that device.
Well, that's just because, okay, in this board here, it has a USB port, okay? On this, what they have is a built-in USB to STLink, okay? The STLink is a different beast,
Okay.
okay? And it's, you know, really powerful. Whereas this, you're just talking USB, you can put a bootloader and things like that on it. Okay, in terms of capabilities, and this is an eye chart, you're talking about in the Arduino environment, 16 megahertz part versus the 72 megaparts for the ARM, 8 bits versus 32 bits, 16K of flash versus 64K, 2K of RAM versus 20K of RAM. EEPROM, these particular parts don't have any EEPROM, but they have a package for emulating it. In terms of I/O, you're talking about 34 to 35 on the blue pill and 51 on the nuclear board. PWM 15 or 16, quadrature decoders, built-in hardware, 4 A to D converters, 12 bits and 10 to 13 pins at 1 megahertz instead of 0.2, DMA, and an interrupt controller, nested vector interrupt controller. There you go. And but it is a 3-volt part. On the other hand, most of the digital pins, not all of them, most of the digital pins are 5-volt tolerant. Obviously the A to D and some of the control pins are not, but most of the digital are. Here's the pinout on the blue pill. And if you, again, another eye chart, here's the pin designation for the ARM pill, and then here are the functions here. So it's pretty rich in terms of capabilities. The schematic here, something important is that for the USB, they have a 10K pull-up. Well, the spec says you have to have a 1.5, so need to put a parallel resistor there. The other is that the port B pin 2, which is also used for the boot 1 pin, doesn't come out to an actual pin, okay? And so the disadvantage there is that if you wanted to use the B port and you're wanting to use, you know, a nibble or a byte's worth of output, you want that pin. So fixing the pull-up resistor is just putting a resistor outboard. 1.8K in parallel with a 10K gives you the 1.5. No big deal. In terms of the lack of the pin 2, it turns out that if you look at the board, in the one corner there's a pair of ground pins. Well, if you sacrifice one of the ground pins by drilling it out and putting a jumper wire in, then you end up with the pin 2 coming out. Okay, so not a big challenge. So there is the same one, I call it a plus, with that, where that pin comes out. And if you will, we can send these around. Here's the one with just a resistor on, and then the corresponding one, if you look at the back, has the extra pin brought out. Okay. Now, if you look at the Arduino environment, what you have is that if you, and normally what you do is under the tools, you pick the board first, and then having picked the board, under the files you can pick, you know, what sort of sketch you want to use. Well, this is for a standard Arduino Uno, and then here is the set of parts that is supported by the ST, and brought here some samples of the sorts of things that they support. And if you will, all the dark highlighted ones are boards that they support.
Your board is no longer alive, Dave. No, I felt the discharge.
He's hefted. All that nice handiwork on the pins.
Now, if you look at these boards and what's available, clearly the blue pill, as I said, you know, is a lot of capability in comparison with a Arduino. But if you need something more, then here's the 411 that a lot of people are planning to use for the alternate CPU, and it has half a meg of program space and 1/8 of a meg of RAM, and runs at 100 megahertz. So, you know, that's fairly capable. But then again, if that's not enough, there's another board there that is the giant board, and it has 2 megs of flash and a 1/4 meg of RAM, and runs at 180 megahertz. So, you know, you've got some growth from the blue pill.
It looks like it's got a lot more pins.
It does. It has 144 pins.
It's about 1,000 times bigger.
The
Yeah.
429Zi, that comes with the display?
No.
Oh, it's the new Clio.
That's the,
Not the
no, that's
separate.
one of these discovery boards down here. It's the, in fact, whoops, I clicked on that and I shouldn't have. Oop. This one down here is the discovery board that does have the display on it, and that's actually the F7, which is the next step up. And as you see, it's, you know, 216 megahertz.
What does this board run? This
That runs, I think, around $25 or so.
Okay, 320 by 240, I guess, display.
Yeah.
That's what 1/4 VGA is.
Yeah, 1/4 VGA, I think. So, I mean, there is growth room here if you need it. Now, again, looking at, if you pick the board, for example, here, picking the blue pill from the list, you find that you've got a lot of sketches available to you, all right? So, now, I haven't tried hardly any of them, but presumably they should either all work or it's a bug and they should fix it, okay?
Are those in the Arduino now, or you can just download those board packages?
I'll get into download, what you have to download, okay?
Is this the one we got?
Good straight man.
Yeah. Full metal.
Now, here is a different picture of what the pinouts are. Here's the list of the Arduino pins, the standard R3 Uno. Here is Roger Clark's, I mentioned him earlier. He's been very active in the blue pill arena. Here is his mapping, and then here on the Nucleo is the mapping that they have. And here you only have about 3 that aren't available that are on the standard Arduino. One of the digital pins and 2 of the analog pins. Now, it turns out you have more analog pins and you have more digital PWM pins. It's just that they're not mapped to that function. You can map them yourself. What I'm talking about, the mapping here, is what comes in the Arduino environment, okay, already pre-mapped for you. All right. Now, you ask, how do we install this beast?
Yeah.
Okay? So basically, you come into the Arduino, you go into the preferences, and you click the additional board URL, and then you use this URL there, and then you click through it. Basically, here is the preferences. You go File, Preferences, brings up this panel here. You take that URL and you plug it in here for additional boards, and you click OK. All right? Now, what that does is that in the contributed list, in other words, if you go under Tools, Boards, Board Manager, here and look at the contributed, at the bottom of the list are the two additions. One is the STM32F1 boards, which is basically your Bootloader, and then the rest of the cores. And so you install those two. Now, as I mentioned before here, this URL is a special one because they've just recently discontinued releasing the F1 as a separate library, and because they're in the process of integrating it in to the straight library, but it's not there yet. Okay, so in the interim, this is what you can use. All right, and so you end up then with essentially downloading these two or installing those two sets into your Arduino environment, and that's all it takes. Okay. Now, in terms of looking at actually downloading something, here what I've used is the standard serial port. Where is it? Where is it? There it is. From Micro Center, standard, FD. And if you, and let's see if I can bring it up here. That one. Okay, there's the configuration. Okay, basically you've plugging in power and ground, and then the two USB ports. Yes, sir.
We only see your presentation.
Pardon? Oh, you only see the presentation?
You'll have to
Okay.
escape to get out of presentation mode for us to see your desktop.
Okay. Well, all right, let's see. Go back.
There you go.
Okay. So there is, you know, the same as the picture I showed you. Really complicated to hook it up.
Yeah.
The other is that you've got to move the one jumper to the pin or the high level. That's boot 0, and boot 1 you leave in place, and there's the reset that you have to punch every time you want to download something. Any questions?
Do you still have your USB port, or are you using that, or in other words, while you're programming it, you have to disconnect your terminal if you're using a serial terminal interface
Yeah.
or a console?
Yeah.
Okay.
Well, you would, okay, actually you wouldn't, I don't think, because what you do is just not plug in the power, because it would be powered from the USB cable. In other words, if you have a USB cable plugged in here,
Right.
it would be getting its 5 volts from there.
Okay.
So you wouldn't plug in the power from that.
Okay,
You would need to plug in the ground,
right, so 3
but not the power,
okay.
okay? Now let's see if I can get back to the presentation. Okay. Are we back?
So how fast is it for a small program if I want to download, you know, a small sketch? Because I work on.
A second or two.
Just a few seconds, that's
Few
great,
seconds,
okay.
yeah. It's no time at all. I mean,
Okay.
it's not any slower than doing a regular Arduino,
Okay,
okay? I mean, it's comparable speed.
I mean, nothing like having to wait 30 seconds. You can feel the life draining out of you.
No, no.
Okay.
No, no.
You know what I mean?
No. And as I said, one of the things about this part is that it's 5-volt tolerant, so you don't need to worry about, well, is it a 3.3 volt or a 5-volt serial?
Isn't that FTDI though switchable?
Yes, they're switchable, but I'm saying, don't care,
Oh, yeah,
okay?
if you forget to switch it.
If you forget to switch it, it's not gonna blow it up or anything like that. You just ignore what the switch position is. If it's 3, it'll work. If it's 5, it'll work. Okay? And basically, like I said, in the Arduino environment, you pick the board, you pick how you're downloading it, which would be serial, and then you pick, okay, what port is it on? And so here, again, an eye chart. In the tools, you pick the board, the form of uploading, and what your port is. Then you pick, for example, the blink as the sketch. You open that up and you hit the compile and download, and there it starts blinking. Okay? Then in terms of, now, the thing that's interesting or important here is that they've set things up, I showed you the pin mapping before, they've set things up in such a way that it knows what pin the LED is on, okay? You don't have to do anything about telling it what pin is that LED on. It uses this name here, which is the LED built-in, okay? And the environment knows to set that up for that part being serially loaded, okay? Now, what I did then was to say, okay, let's go ahead and do serial port stuff. And because it's downloading over the serial port, it knows that, okay, that's a USB that I can send stuff back over, just like an Arduino. And so it's fine, you just put down its serial begin, just a standard Arduino. And the environment knows that if it's a blue pill that you're doing serial downloading from, the port is the USB 1. Okay, I mean UART 1, okay, and it just hooks it up, and you know, you do hello world and away you go, okay. You just hit the go download, and you know, by the way, if anybody says, hey, let's see that, I can do that. I can switch it out, and then here you know, click on your monitor, and then there it shows. Okay, so now, like I said, as long as you're not getting out into some of the more esoteric and fringe things, it'll probably just work right out of the box. Okay, but I've also had problems along the way in trying to do exotic things. Okay, now. Here's going through the process of downloading the bootloader, okay? It's fairly involved. You've got to install the Maple DFU and the SD Comm drivers. Here's where you get them. Here you unzip them and that's where you put them. And then you do an install of the two drivers and you reset the computer. Okay? Normal thing. Then this is so that you can talk to it after you've got the bootloader downloaded and installed. Then to download and install the bootloader, you need to get this package from STMicro, and you also need to get the binary, and there are probably a dozen or so different variants on the binary. There's the blue pill and the black pill and the this and the that, different ones, and the point is that it depends upon which pin the LED is on as to which one you want to use. Now, the most common blue pill is this generic PC13 is where the is. If you look at the board itself, you can see it says PC13 right next to the LED. Now, the other thing is that, and it's probably operator error, I haven't been very successful at using the bootloader. It appears that Windows 10 doesn't play nice with them, and it looks like every time that you it does an update or who knows what, it loses the drivers and you have to come back and do a reinstall of the drivers, okay? I ended up saying, to heck with it, I'll just use the serial download and be done with it. I would really have liked to have used the bootloader, but that's for another day, okay? Again, you know, here's the standard setup that we had before. And you open the STMicro flash demo program, and it comes up and you specify which port it's on, and obviously you may need to use the device manager to make sure which it's on. And if it recognizes it, it'll come on to the next one and identify the target. And going forward, it'll tell you about the part. Then you get up to the point next where you actually have to specify where's the binary you want to download, okay? And you go pick it, and in my case, I just use I use the binary that I mentioned, and you put that in, and you click the next, and it goes forward, and it hopefully says done successful, okay?
I guess since you can't debug in the Arduino IDE, you're not really losing anything, right? I mean, without the
What do you mean?
bootloader. I mean,
No, there's no, in fact, the thing I'd say is that the Bluetooth, Blue Pill, you can program with the bootloader, you can program serial, or you can program with a STLink, okay? The STLink plugs into the pins that are sticking out horizontally, and you can program it any of those three ways. Now, with either the serial or with the bootloader, you have the advantage of having a serial comm coming back, okay? If you're using the STLink, there's not a serial, okay? So, now, the advantage of the STLink is that if you're using it with, say, a industrial strength IDE, like the Atolic True Studio, you can do breakpoints and stepping and look at registers and all that sort of stuff. If you're using the Arduino environment, lots of luck in terms of finding anything out. You're stuck with using printf as being your only window into anything, okay? And so, anyhow,
The old scope loop,
Yeah,
toggle a pin.
exactly, yeah. Well, printf is a little better, but anyhow. Then afterwards, then, you know, you've got to remove all the stuff and set things up. And again, you better find, looking to make sure which port your bootloader is showing up on. Now, here's where some of the stuff gets a little tricky. One is that if you come up and it has a question mark and its maple is listed under other devices with an exclamation point, says you don't have the driver, okay? Go load it again. If it is, then on the first time, the very first time before you've downloaded a sketch, it will be permanently looking as if it is a maple DFU. Once you've done the first sketch, it will switch over to being the virtual port, and you will have to use the show hidden devices for the maple to show up. So downloading the sketch, using the bootloader. In the case of the board I'm using right now, I don't have the resistor soldered in, so I've got it as a jumper. Make sure that you put the boot back to the boot 0 on both of them, and plug your USB in, and you're ready to go. Now, when you look in the device manager, after you've done the first download, you'll see with it in show hidden devices, you'll see the maple as a one that was there before but isn't there right now, and you'll see the maple serial, which is your Comm, your virtual Comm. Now, what it does, okay, and then you set up that says, okay, whoops, shouldn't do that. Blue pill, that you're using the bootloader and what port it's on, okay? I mean, what port your virtual Comm is on. Now, again, like I said, you want to make sure that it doesn't show up as other devices, in which case you need to download your, or reinstall the driver. Then doing the blink, you just, open that up and download, compile and download. Now, as I mentioned, before you've done the first sketch, the virtual Comm won't show up, and it will just have the maple. After you've done the first sketch, the maple will show up as being something that was there before, and that it's virtual Comm now. Basically what it does, which is the same thing as when you're programming with the Arduino, it switches modes to where it's using essentially the serial port or the USB port for downloading, and then it switches back to being virtual. And they've got some trickiness in how they make the thing switch back and forth. I won't get into those grubby details. Okay, then the other is that I'll talk about using a STLink clone. These STLink clones, they're again, really expensive, about $2 from China. And the thing that's interesting about it is that it is just that. It's a clone that they've programmed with the same part and software as ST Micro's STLink, and it will, you can update it just as if it were an official ST one. My guess is, some of the people take and go out of their way to make sure that people that use clones of their parts won't work with their updated software. My guess is that ST Micro is just as happy that they have one, okay? Because they're not making money off of that, okay? They're making money off of selling parts. And if people use that to, program their parts, so be it, okay? So my guess is that they will always, support that clone, that they won't do things to make it so you can't use it. As I said, that one is, you can get it for about $1.76 with free shipping. Expensive parts. Okay, to update the software or the firmware, here's the place that you go to get the software that allows you to do the updating. And here's the utility that you get. You plug it into your PC, you fire up the STLink utility, it says connect to target, and here's the process. Basically showing it in sequence. Here you've opened up the STLink utility, and you say, okay, connect to target. If it can't find it or it's bad, it says, gives you a message that says "Nyanya." Otherwise, it says, oh, okay, yeah, I see that. And you tell it to go ahead and update it, and you're done, okay? I'd suggest that if you have either a clone or if you're doing a Nucleo board that has an ST-Link on it, then you go ahead and update the firmware so it's up to date. Okay. Downloading a sketch using the link. Now, as I mentioned, there is no virtual comm with the ST-Link, okay? You don't have that. So, again, you remove all the cables that you had before, and you plug it in, and as I said, from the ST-Link board, it's the 4 wires that plug into the 4 pins that are sticking out. You've got to get them in the right order, but anyhow, no big deal. And then it will show up, it should show up in the device manager. Whoops, I keep forgetting and clicking on that, as an ST-Link. And then you say, okay, you select your board, you select the download method, and pick your sketch that you want, and do a compile and download. Away you go. Now, you can do the same thing with the Nucleo board, the difference being that in the case of the Nucleo board, just like with the Arduino, they use one of the UARTs through the virtual comm. So in the case of the Nucleo board, you do have a comm available. Okay, that's one of the main differences. And again, you just go through the same sort of sequence. It will show up. Now, in the case of the Nucleo board, it shows up as a lot of things. It shows up as a memory port as well as an ST-Link. Then in terms of downloading, you pick the Nucleo board, the method that you want to download with, and if you want the virtual COM port, you pick that. And then you go ahead and pick your, in this case I was using the Blink print that I had done before since I have COM available, so I picked that and did the compile and download, selected the monitor, and sure enough it showed up. Okay, so now one of the things that can happen is that since you are sharing pins, or you may have programmed the pins, either the serial pins and or the ST-Link pins, if you have those programmed inadvertently or intentionally as part of the functions that you want to do, then the problem is that when you are trying to download something, you've got to get the reset in the right sequence with when you are actually trying to send the code to it, okay? And the problem is that it stays in the reset mode a very short period of time, so the likelihood of you being able to push the reset button and get it to download is between slim and nil. So the way you solve that is that you use the STLink Clone, and it has the reset pin or the reset control part of it. So you actually plug that into your board, and that way it is controlling the timing on the reset. And that's how you can take and get one of your bricked blue pills back into shape, okay? Because it understands how to do the critical timing, and it does it right, okay? Questions, comments so far? We're going to switch gears a bit.
Have you had to do this yet?
Pardon?
Have you done this yet?
Yeah,
Yeah.
yeah. In fact, I did break it and say, oh shit. But fortunately, I have a way of getting out of that.
Okay.
Okay, so yeah, it does work. Okay, now, like I said, I can demo any of these things along the way if you say, hey, well, stop, Dave, and actually demo that to me. But since we've got a lot to go through, we'll forge ahead.
Yeah.
Okay. Here's, going back, set things up right, get the jumpers in the right position, and make sure the old serial ports are removed or out of the way, and get the clone going. And then you just step it through, just like it was any other one, except in this case, for the download method, you pick the STLink as opposed to something else. And you pick any sketch you want, and away you go, okay? So, now's the intermediate. Here's where we're getting out of the area where we're just using sketches, okay? We're getting to the area where it gets a little tougher, okay? In particular, we were working down in this area here, the easy area. Now we're going to jump up to this one. It says, okay, unfortunately, you don't have things like the STM Cube MX available to you to actually do the programming, and so you're pretty much left having to figure it out brute force from the manual and set the bits yourself, okay? So in terms of the effort, it's a big step. In terms of the capabilities, though, that are available to you, it's a big step. Now, let's look at the differences in the parts. We were looking at that before. Before we were looking at just these parts here, doing it with sketches. You also have all these parts available, and you can run sketches on these. Presumably the sketches, in theory, will work, okay? But only from this list. There's a whole bunch of other ST micro parts that don't have or haven't been added to the capability, okay? In theory, in fact, there's a link in the beginning that shows you, if you go in there, how to do it. It's above my job grade. All right, so let's take a look at looking at the data sheet versus, okay, here's all the stuff you need to download, all right? You need the data sheet, you need the reference manuals, and the user's manual for the HAL. A little, you got about that much documentation, okay? But you can also take and download now. Like I said, the Cube MX will generate code which will go into industrial strength IDEs like Atolic, but it's not very easy to put those into the Arduino environment. Okay, in fact, the handle broke off for me when I tried to do that, but be it as it may. Okay, here's how you download it, how you install it, and how you can make it appear as, here is the blue pill in the, in other words, following those instructions, you can get the blue pill with all of its corresponding I/O labeled. Now the thing about the Cube MX is that you have this list here of all of the internal peripherals that are available. And you can click on them and set them up. In particular, to set this up so that it looks like the blue pill as is, I went into the clock system and told it had a crystal or a resonator on both the crystal as well as on the watch part, which is what the part has on it, okay? It has those. Then I also told it about that the timer, that's the built-in timer, which is the sys tick, is there, and how to hook it up. And then I also hooked up the LED. So basically here what you see is how that part exists before you start trying to add anything to it. That is, here's your LED, here's the various, the UARTs, the USB, the boots, and the clocks and the LEDs, okay? So it's there it is, ready to go for you to start playing with it, okay?
So one quick question on
Yes.
the Cube MX. Can't you tell it what board or part you're using, and it would configure that
Now,
beginning
yes,
state at least that much for you?
yes, but it doesn't know about a blue pill,
Oh, I didn't know about
okay?
it.
In other words, in the case of the blue pill, you have to tell it what that board is, because it's a foreign notion to it,
I got you.
okay?
Okay.
So what you have to do is you have to pick the F103C8 part and then populate it.
Go configure
Now, if it was a
accordingly.
Nucleo board, you just picked it as the Nucleo board and there it is.
Yeah, and it tells you the default state of a nucleo.
Right,
Yeah.
exactly,
Okay.
exactly.
So there's no easy blue pill selection.
No, not yet, not yet. So, okay, so, like I said, now, this is very useful for saying, okay, what are my peripherals and how can I set them up? What can I make them do? It's not useful for actually generating the setup code to use in the Arduino environment. If you're using Atolic or something like that, yes, you can. But not yet, maybe sometime in the future, okay? Like I said, this is a very new capability. I mean, it's only a couple months old. So,
So the output of that is not like just a text file that you can.
oh yeah, it's a text file, you can read it, okay?
Bunch of text
But-
files.
But it's about 6 or 8 files, and okay, now where do I put them? How do I put them into the setup part and the loop part of an Arduino?
Yeah.
Okay?
Yeah.
Now, if I were an Arduino environment expert, I could probably tell you exactly where to pick up those files and how to put them in and how to tell the Arduino environment how to find them. I'm sorry, not that expert, okay? And I'm sure at some point in time, somebody will come out with an app note or something like that, of here's how you do it, but not there yet. Okay, now, so here is, if you will, side by side, the picture that I showed you from the Cube MX versus the standard blue pill. And the difference here is that the standard blue pill doesn't tell you everything you can actually do with all this stuff, okay? Whereas with the Cube MX, you can punch in, what do I really want to do with all that stuff, okay? And it can tell you, here's what you can do. Now, it leaves you to figure out how to do that with this stack of documentation, but, you know, in principle, you can do that. Okay, so I said, all right, let's try doing, with hammer and tongs, the blink, okay? So I said, all right, here it is in the Cube MX. So I've loaded that up. And one of the things here is that when I loaded it up, I said, huh, interesting. It says the clock configuration says, there's an error there. Wonder what to do about that. Well, let's open up the configuration. And it says, oh, would you like me to fix that for you? You click yes, and it does it, okay? Basically what it does is it says, okay, since it hadn't set things up just how it came up, certain of these things are overclocked or what have you, and it says, okay, with this particular input, I can set each of these to their maximum frequency, and that's what I'll do, okay? Again, this is great if you're going to, say, a Tolic or something like that. It's worthless if you're going to Arduino, because the Arduino environment says, well, that's how I'm going to set the clocks up anyway for you, so don't worry about it. All right? In other words, in the Arduino environment, it sets all this stuff up for you. You don't have to worry about this kind of setup. All you have to worry about is if you're using a peripheral that isn't part of a sketch, then you're on your own, okay? Otherwise, you know, it's gonna be there. Okay, now, well, since we're doing the, basically just toggling a pin, we're going to go look at the GPIO, general purpose I/O configuration. And what you do is you bring up configuration and you look here under system and the GPIO. You click on that and it says, okay, here are the two pins. Let's see, what was that one? Oh, the PB2 is by default a input for the boot one, okay? You can change that and do whatever you want to with it. And the PC13, which is the one that the LED is on, and we label it LED, is an output. And since we said that it was an output before, it said, okay, well, then that's probably a push-pull, and fine, it's all right, the way it is. We click OK. Now we can actually, in this case, I'm actually going to look at the code, show you what the code is. You punch it out. And I picked True Studio as the target. There's a number that you can pick from. Unfortunately, Arduino is not one of them, but anyhow, so click all right. And here I said, okay, now back here, one of the things I did was I set up where does it go, and I set it up as being STM32 Arduino workspace, and then here was the blue pill. So that was the setup I had done to where it was going to go. So I do the project, generate the code, and voila, it does it. And you get the progress. Here it does take more than a second or two. And you can say, okay, let's either open the folder where it's put all the code, or you can say, open the project. Now, if you have the Studio installed and pointing at the same directory, it'll magically open it up, and here you are in the Atolic True Studio, and they're ready to go, okay? And if you're in there, you can open it up, and if you open up the directory, you have the application, and under the application, you have the user code, and lo and behold, there's .main. Here's your .main, and it looks almost just the same as an Arduino environment. Here's your loop, gives you a while. Here is the calls that it has for the initialization, because it's generated all the code for the initialization, and so it, in the main, calls that first, and then says, here's your loop, and it has scattered through it these user code begin and user code end for you to stick your own code in. Now, with the Cube MX, if you stick your code in the places it says, here's where your code goes, then you can go back into the Cube MX and change things, and it will leave your code alone. It won't muck with it, okay? It'll change the stuff you asked it to change, but it'll leave your code in place alone, okay? So that's nice that it does that. Okay, now, and if we look at the details of what's in there, we have here's in the generated code, there's the drivers, that includes the source, True Studio stuff. In particular, the drivers are all of the ST Micro core, if you will, routines, the HAL routines, all of those are sitting in the drivers. Huge set of stuff. In the include, there is the main and then two more files that it's generated. In terms of the source, it's got the main and it has the actual code that's going to do the initialization of the I/O for you, okay? That's the routine that it's going to call, and as I said, it has the while loop that you put your normal loop code into. And then there are, like I said, there are altogether 7 files that it generates, okay? Now, if you are running in, say, an Atolic, it needs to have all those 7 files because they're all things that are important to make it work. In the case of the Arduino environment, about half or 2/3 of what's in those files is already built in, setting up the clock trees and all that sort of stuff. But the important stuff that you've decided that you want to use, it won't have done it for you, okay? And it's scattered among those, and when I tried to do a more complicated one, that's where the handle broke off, okay? In the case of the simple one, it had put all of the code that I needed into this one routine in main that if I just copied it over, fat, dumb, and happy, okay? So let's go take a look at what we've got. In the main.h file, we had the definition for the pin and the port that the LED was on, okay? In terms of the main code, it called the MX GPIO init routine, and down the way, here was what was in that init routine. And among other things, one of the things is that on any of these setups, when you, and the ARM has gazillions of registers and bits to set. It's fearful and wonderful what you can do, but it's also a minefield in terms of all these bits you need to set. One of the things that's important is that any of the sets of registers that control these things, you need to enable that section's clock before you start trying to put bits into the registers, or you can't get the bits into the registers. It just says, yeah, man, I will, Okay, this is one of the things I stumbled across because I didn't have things in the right order and it didn't work. But, so anyhow, here is the routine it's calling, where it's a HAL routine. It says essentially the clock control section for the GPIO C, enable the clock. Because we're doing it in port C is the one that that LED is attached to. And then here, one of the things that we said was that initially we wanted to have that port in the 0 state. So there's the command it's saying, okay, put it to the 0 state. And then here is all the setup stuff that it's doing to set up all the registers. And we'll look at that in a minute when we look at what's in the register definitions.
Just one note.
Yep.
You're pointing at something, we don't see your mouse.
Oh, I'm sorry. Okay. All right.
We're going by the arrows.
But if you did the escape thing and went back into normal PowerPoint,
Well, I can just stand up.
or you could stand.
Okay, here's your definitions. And over here is the code where it's saying, okay, before it does the while, it's calling the init. Here's the init routine. Here's the one where it enables the clocks for that port. And then here's where it's doing the setup. Okay? And so I said, oh, okay, well, let's just copy that stuff over. And here is the code that I just blindly copied it into a sketch. Okay? Here's my setup. I said, okay, do the init. And up here, before I get there, I have to define, that routine so I can find it with a prototype for it. And then here's the loop, and in the loop I used a HAL routine. Remember we saw how it set it to the reset state. Well, there I'm setting it to the set state and the reset. See me? And so, stick in normal Arduino delays. And then here's I just copied it in. There's the routine that's going to do the initialization. Okay? Like I said, fortunately, it was just a little bit of code to do I/O ports. When I got into doing the decoder, a little messier. And then fine, okay, our standard serial, and downloaded it, and lo and behold, it worked. Okay? Now, then I said, okay, let's try doing the same thing, just using the reference manual, okay? We used the code that CubeMX generated. Now if we didn't have that code, how would we do it from the manual? And first of all, fine, here is the thing that says, here's the register that does all of the clock control. And in particular, there's the one for the port C. So we want to set that to enable. And then we need to go look at how we set up the port. And here's indeed how the port 13, there are two registers. There's the high and the low that have 4 bits for each of the ports, and you have the setting it up as to what mode it's in, whether it's input or output mode, and depending upon whether it's input or output, whether you have pull-ups or pull-downs or what have you, okay? And in particular, now, since when we want to do the setup, first of all, you don't know what state those bits are going to be in. They might have been set up by something else. And in particular, in the case of the Arduino, you want to make sure that any Arduino setups you put before the stuff you do, because it's liable to come in and mess up your stuff, okay? But you don't want to mess up the stuff it did. So what you do is you go in and specifically clear out the bits that you want to set and set the bits, or conversely, you can put that into a one-liner and clear them and set them at the same time. Okay, it's a read, modify, write process. And then the next is you finally get around to what you're going to put in the loop, which says, okay, put it high, put it low. And in this case, since it's a single bit that you're mucking with, you don't need to clear it first. You can go set it and clear it individually. And then here's the code that does that. And it's a lot less code. I did use and as you can see here, the form is that you specify essentially what register bank it is, and then the specific register within that, and what you want to do with it, okay? Gary, I'm busy right now. Call you back. And then here's where,
Hopefully she didn't fall down a well or something.
no,
Okay. She'll call back.
Just go for the positive view, Roy. Just
Sorry about that.
at least I don't think she did.
She'll call back.
You'll find
She'll
out.
go, I'll find
Yeah.
out later.
They'll just try to-
She can swim pretty good.
Yeah.
Well, but if she broke her leg, she fell.
Just dig it deeper.
Okay, I'm shutting up. Go ahead, sorry. Hey, listen, you're talking to a guy who does a lot of this
Please,
stuff.
you're making me feel happy.
Okay.
Anyhow,
He's gonna give you the number, you can call it.
anyhow, so here's where we're setting it up in the setup, okay? And as you can see, when you're doing it at the register level, it's not really all that hard, okay? It's just that you gotta find out which registers you gotta do it. And the thing you gotta remember is to enable that set of registers before you do that.
So did you have to figure out what the addresses were of, you know?
No.
Okay.
No, remember back in the manual, it says, okay, here's the register name,
Yeah.
okay? There's the register name.
That's
So
equated
it's-
to it. That's
it's-
equated to
It's
it.
equated to it.
Yeah.
There's
So-
that's
so the
part
difference.
of all of this stuff that ST Micro made available, is they put all of those definitions, all those register definitions in there, okay?
Most all of them. Sometimes I've had to look up the physical address. And put it in.
Yeah, some of them they don't. Yeah,
Oddball.
that's why I said, you know, buyer beware, you know, the
What do you want? $4, $2.
but the thing is that what it's defined is, it has this location is defined, and then it has a structure that has all the sub-registers that are associated with that function, okay? And there is our loop. And, you know, set it high, wait. Now, in this case, I went ahead and used the HAL internal, the ST Micros delay routine instead of the Arduino. I could have used the Arduino one, didn't matter. But just to show that there is one that is provided as part of the HAL, there it is, okay? And it's just the same sort of thing. And part of what the environment is that you've downloaded and installed is essentially it makes the mapping, performs that mapping for you, okay? And whoop. So went ahead and did it. The next thing was okay, in Arduino, you can do bits, set bits and clear bits in register in the I/O, but you can't do nibbles and bytes and stuff like that. Okay. Well, if you're doing it at the register level, you can. In terms of the setups, as I mentioned, you've got to do the I/O, and there's a 32-bit register. All of these things, all of the control registers are 32 bits, okay? They may only use 16 of them, they might only use half a dozen of them, but they're addressed as a 16-bit register.
32-bit. Pardon? 32-bit register.
32-bit, I'm sorry, 32-bit register. In terms of the setting and clearing bits, we saw how we can clear bits and set bits. You're only dealing with the lower 16 on an I/O register, okay? So this is the data out register of the GPIO A, B, or C. Now, they also for I/O do provide, because these are essentially a read, modify, write, okay? They do provide a special set of registers that allow you to do those in an atomic way. That is, you can set bits, clear bits with this particular set register, and these are 32 bits where it's a pair of bits for each I/O bit as to whether you want to set it or clear it, okay? And so as one word you can send out, you can set up any bit pattern you want on the 16 bits of I/O. And you can either leave them alone of whatever they are now, or set them to a particular pattern with that. They also, I don't know why, but they also have another register that's just used for individually clearing bits. Looks redundant to me, but anyhow, they did it. Now, writing multiple bits, like I said, you, whether it's a I/O or whether it's a control register, you need to clear the bits that you want to modify, and then set what particularly set. You can either do that as a two-step or as a single step. To read, modify, write. Okay. Now, here's where I, don't do something easy, do something really bizarre. Using the quad decoder, one of the counters for a quad decoder, is probably one of the most complicated things you can possibly set up, okay? But it's clearly very useful, at least for the stuff we do. And so I said, okay, let's do that with the Cube MX first. Well, with the Cube MX, pretty easy. First of all, I just, we had our blue pill there, so we bring that up. All right. Now, in the blue pill, what I said is, okay, here, I'm gonna use the timer 2 for this quadrature decoder. You just come down here and you say, oh, well, let's use the encoder mode. It says, oh, okay, you want to do a quadrature decoder? Okay, I can do that. And it shows up as being those 2 channels there. Okay? Then you go into the setting up the configuration timer. Here is the what you get back in terms of the configuration for the timer 2, and the things that it comes up as default is it has 0 for the reset value. In other words, when it rolls over from 0, what do you want? Okay, well, the default is 0, so it's not very useful for what you want. You want to roll over to the max number. Okay, so you got to put that in, and it's a 16-bit register, so it's 4Fs. And then the other is that if you look in the manual, and if anybody's played around with the quadrature decoders, you know that you really want to look at both channels, because you're sitting right on the edge of one and rock back and forth. If you're not looking at both channels, it'll either be counting up or counting down, as opposed to counting up, down, up, down, up, down. Okay? So you need to tell it to use both channels. Okay? Now, the manual, the documentation, is a little misleading because it says you want to use both edges. They really meant both channels. And if you can go in here and say, instead of rising edge or falling edge, you can say both edges. Well, turns out that that won't work, because now it turns out on the 103 it's all right because it ignores that fact, okay? But if you try to use that on the 411, it goes, yeah, I don't know, I'm out of here. It doesn't work at all, okay? So I had that problem when I was using the 411 and couldn't get my quadrature decoder to work. Well, that was the reason, okay? So use rising or falling edge, not both, but use both channels. And in my case, since what I'm using is the little Tanner quadrature switch as my test vehicle, that will alternately switch one or the other, or to both, to another pin, say ground, then I wanted to pull up. So I said, okay, over here, in terms of the, again on the timer configuration, I want to set those to both pull up, okay? No big deal. So, okay, fine. The usual setup to generate the code. Go generate the code and look at what it's generated. Okay, well, fine, it's got the timer. Says, there's my timer in it, there's my GPIO in it, and then, oh, well, let's see, down here in this, it's got some, another encoder in it, and uh-oh. We've got some software that's scattered around, and where are we gonna put all that stuff? Oh, by the way, I use Notepad++ for viewing the code. That's a very good package for viewing code.
Does it split the line feeds?
So that encoder you got from Tanner's, is that a mechanical rotary?
Yeah.
So this is a good example because I assume that it'll filter noise because of the quadrature encoder logic.
Yeah. Well, what it is,
it's real pain.
Well, what it is that, remember we've set it up so that it looks at both channels? If there's noise, it says, so what? I go, blit, 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 blit.
Yeah. Okay. Wait. Okay. Got it.
Okay. Now, you can also set up a filter on it, all right? I haven't bothered with the filter. Okay, it seems to work fine. And again, that's starting to get off in the, I'm not sure what it's gonna do or how it's gonna work. So I left that part alone. So anyhow, here's the code. Set up the GPIO, set up the timer. Here's the GPIO. Oh, all it's doing is enabling the clock. I wonder where all the code is that sets it to pull up and pull down. Interesting. All right, so here's all the timer code. Oh, off hidden on the side here is some other, okay, here's all the timer in it. But it's calling all these other funky routines that are scattered around. Wonder what the heck those do, or if those even work. Okay, well, let's see what we got here. Well, if we kind of look at the pattern and then look at the pieces of code, here's the code that looks like it sets up this part here, and the code that sets up that part, and the code that sets up that part. Where's the stuff that does the I/O? Well, if we hunt around a bit, we find that under this mysterious routine, it defines the I/O structure. Oh, here it configures it there. I wonder how we put those pieces together. Very carefully, I guess. Okay, yep. Pulling those little pieces out and seeing, matching it up to what I put in. Yeah, I can see that it makes sense. Okay, so let's give it a try. Here's the code that's, pulling those out, and yeah, I needed a handle and that stuff. Okay, and they're set up. I call those. Okay, yeah. And there was the code for the setting up the timer. Here was an attempt at pulling together stuff that does the I/O into a separate routine, enabling it first, doing that stuff. And okay, let's compile it. Well, gee, structure that. No member auto reload, preload. Punt.
Next.
A shovel came out of the screen and said, "Here, you do
So, conclusions. Give that back to great graphical representation to look at what peripherals you got, what pins, etc. And it does generate code, but you might not be able to get that to compile if you try to pull the code together. Now, if you were an Arduino expert, you might know exactly where to put these files and where to put the pointers and all the stuff. I'm sorry, that's above my job grade. Okay? So, yes, ma'am.
So is any of it tied to the bootloader sequences? Would that might be why?
No, well, if we go back, whoop, we went forward. Okay, these error messages are because there's a bug in the packages they've released so far.
Oh, the generated code?
No. The packages that came from ST Microelectronics that you plugged in way back when.
Oh,
Okay, they don't have everything defined.
okay.
That you're
Okay.
missing probably.
I mean, it's 2 months old, and it's fresh
So you only have to go to
new
the
and
reference manual and
Yeah.
dig up the register definition.
exactly. And in fact, if you go look at the code that came out of the Cube MX and look in the driver file, you can find where this is defined, okay? And you can hunt around in the Arduino code and find out, oh, this is where that was supposed to have been defined, but the line is missing. Okay, we'll see that in a minute, okay? But here was one where I said, pfft. Okay. The handle broke off.
It's left to the casual observer.
Yeah.
So, like I said, the Cube MX is very valuable to see what can I do with this beast, okay? What's available to me? What are the things I have to do, okay? And that gives you sort of an entry into the manuals as to what registers do I look for that I need to set up, okay? But the code it generates, number one, the HAL code is kind of bordering on bloatware. You saw that in the case of where I was doing the toggling, the blinking, the code I had versus if you looked at the number of lines of code that they were using to do the same thing. But hey, you know, if you got the space and the memory and it works, hey, don't mess with it. Don't mess with what works, okay? But so it's, to me, it's very useful. And obviously, if I was using Italic, it great, because it sets everything up for me. But be it as it may, so I said, all right. The next thing is to say, all right, well, let's go look in the reference manual. But it's given me a hint. Yes, sir?
Just a moment. So if you're using Italic, so would this have worked with Italic?
Oh, absolutely.
Okay, so this is just an exercise to see how we could use Arduino instead of Italic.
Exactly.
Okay.
Exactly. In other words, this is all Arduino environment, okay? And, you know,
Okay, so it works in some cases and not in,
yeah,
as well in others.
yeah.
Okay.
Well, what I'm saying is that in the Arduino environment, it gives you a good roadmap as to what you can do, okay? But doesn't solve the problem for you, okay? In the case of using Italic, it does all the heavy lifting for you, okay?
Okay.
Which is beautiful, because there are hundreds of registers and thousands of bits that you have to set for it to even come up. So anyhow, let's take a look at what we're gonna do there, all right? Well, we had, all right, where are we? Am I off somewhere? Okay, so it says, all right, looking at the reference manual, reading out from the reference manual, it talks about actually what you need to do. It says, you know, in this section, encoder interface mode, okay? Talks about that. It says you can do only one. It looks at both to know which direction to count up or down, okay? But in terms of which edges it uses to do the counting, you can either do it on one channel or the other or both, okay? And the recommendation is that you use both. Okay, you can also select both edges, and it talks about the fact that if you are wiggling about one of the points, this will take care of that. And it says, okay, here's my example in the book, straight out of the book, section 15.3.12, and it says, you know, here's all the values. And then it has an example of the waveform, and here's where you have jitter, and it shows that it counts up and down properly with jitter. So this is why my notion is, why bother filtering? It's gonna, the jitter isn't gonna be fast enough that it can't keep up with it, okay, since it's in hardware. Software, yes, but hardware, I don't care.
Was that only a 16-bit timer for?
Yes.
Quadrature?
Yeah.
You're gonna have to handle the overflows.
No, okay. Here's the point on what you do and how you do that. let me come back to that. Good point, but you don't worry about, okay, the 16 bits, the only issue is, will it wrap around more than 16 bits worth between the times you read it, okay? In other words, will it count more than, say, half of that? Will I have more than 32,000 counts between the times that I read it? If I am, then yes, it could be a problem. If not, I read it again, do the difference, and cum that in a 32, 64-bit, however much I want. No big deal, okay? And if you look at the math, even when it wraps, you still get the right difference, okay? It does work. Okay, so it says, all right.
You mean it's, okay, two's complement, okay. You mean it's like if it wraps negatives, then you sum it, it acts as a negative?
No,
Nope.
no, you
Oh,
just
gosh,
take the difference.
beyond the-
It just wraps, it doesn't.
All right, well,
Do-
okay, think about it. I'll
Think
think
about
about
it,
it.
think about
And
it, it
we'll-
works. Okay, so here's the timer configuration we need. Here's what, copying out of the manual says, here's what we need to set up, okay? So there's a one-to-one. Here's what we had from the, essentially copying over from, or looking at what the Cube MX showed us. And here, matching up the code that it talks about, here's what you need to set up. And so, okay, go find the registers. Well, all right, we need to enable the timer. All right, there's that bit. Enable it.
So you're really favoring this for the Arduino environment? You're
For the-
favoring having register?
In the Arduino environment, what I do is I'd use the Cube MX for hints as to what it is you need to
Right,
do.
okay.
Okay, and then use the manual.
Okay, because you don't want all that HAL stuff and all those.
The house stuff is all right because you got enough space to who cares, okay? Unless you're running short on memory, I wouldn't bother with it, and that's why, for example, the Cube MX generated code is, yeah, it's bloatware, but so what? It runs once and it sets stuff up, and who cares? So in a True Studio, I just use it, okay? Here's the setting up the encoder, and we wanted to have both edges. And then here's the capture bits that we need to set up. We're setting up the 2 channels. And then we're having to do the, set up the compares. Again, and then we're needing to set up the reset values, okay? And so there's the registers. Oop. And so it says, all right, here's hand-generated code. There's what it takes to set the thing up, okay? And then here's what I did for the loop. Basically, once a second, I would toggle the LED, and I would output the values. And, there was a setup. Okay. And now, one of the things that's, the ST Micro has is a so-called HAL callback, okay? What this is that it's a user routine that it will call once every millisecond. Now, unfortunately, again, this is one that's broken. They know about it and they said, yeah, we'll fix that next release. Here's where it is. And so here's the places it is. This is the STIC handler and it increments the counter, okay? But it needed the interrupt handler, and the interrupt handler is the one that does the callback, okay? So this is what it is now, that's what it should be and what it will be in the next release. If you go in there, you know, go find the places it's broken, go fix it, okay? And voila, it says fine. Here's, I set it up, said, okay, what I'm gonna do is I'm gonna have a flag that once a second, I take the flag and turn it to true, and I look for it in the loop. And I'm gonna use a counter that I count to 1,000 or count down from 1,000. And so here in my setup, I say, you know, I just set up hello world so I can see is it working. Here's my loop. I say, okay, if the flag is true, print out that I had a 1 second tick. And set the flag false so that the next time around, you know, I gotta toggle it back and forth. And then here's my HAL routine, really complicated. It says, well, take the counter, and if when I decrement it, it's less than 0, set the counter back to 1,000, set the flag to true. Okay? Now, if I were using the quadrature decoder, what I do is right in here, I would read the decoder and set it into a volatile variable that my loop can look at, okay? So here's where I put whatever code I want to execute once a second, 50 times a second, whatever, okay? And there it is, okay? Any questions on it?
Isn't it 1,001? No, I always get that wrong. Looks like. That's what, to this day, I couldn't tell you. Does that loop get executed 1,000 times or 1,001?
Or 990.
Or 999?
Yeah, I don't know. It's close enough, right?
Probably one of those three. I agree with you. The probability is 99% that it's off by 1.
Yeah, okay.
Okay?
That's it.
Okay. I haven't checked it, but yes, one needs to be very careful of whether I do a pre or post increments and decrements and what's the value I use, et cetera, et cetera.
Ah, you got it. It is pre, so you got it right, I think.
Okay.
I made the mistake.
Okay.
Okay, I'm shutting up. Go on.
I don't believe it. Can you speak up? Would you speak up for my microphone here, please? Okay. Whoops. So that basically concludes, you know, here's sort of my wrap up getting off the stage. Assuming you're currently using the Arduino environment, this is a great way to get started using the ARM processors. It's easiest using the existing supported sketches. Those will probably work right out of the box. High probability, you know, since it's new, no guarantee, but there's dozens of routines, probably even over 100 sketches that are already out there and they'll work, okay? Of those, probably 5–10% won't, but hey, buyer beware. The serial and STLink worked great for me. The bootloader was problematic for me, but my problem was probably my lack of experience in knowing how to actually care and feed for it properly, but hey, you know. So I just stuck with the serial one because it had the advantage that it would do monitor stuff and it would load stuff with every time. The only thing I had to remember was to put the jumpers in the right place and to push the reset button. I kept forgetting to push the reset button before I did the compile and download. Yes.
So I've got one of the older Arduino Megas that
Yep.
had that bootloader problem, and every time we tried to fix it, it just bricked. And so, I mean, I'm still got it stuck in a box somewhere. Is this something that might be compatible with that? Although if you've had trouble with the bootloader, would it fix it?
Well, first of all, since it is an Arduino, okay, this is an ARM. Okay, so the bootloader for the ARM is very different than the bootloader for an Arduino.
Gotcha.
But on the bootloader on an Arduino, there is a separate header that presumably you can
Take out the exclamation points.
Yeah.
Asterisks, yeah, right, that didn't work.
Okay.
Yeah, and then you did that whole reset, push the button fast, yeah, that's
Yeah,
another in that.
yeah. Well, that's why, like I said, if you bricked your blue pill, why the STLink with the reset wire gets you out of the problem. Okay.
No issue with those.
The ST-Cube, the Cube MX is great for design exploration, not very good for generating code.
Just go to Micro Center and get one for $10.
Technology is only useful for the boards listed, okay? If your board isn't listed, remember I showed you the list of boards that's supported. If it's not in that list, lots of luck. There is a link that tells you how to put a new board in there. Lots of luck. Okay, the register definitions and their usage appears to be pretty solid. There's a hidden register that has to do with hardware debugging that's in there that I couldn't access, but your normal registers are probably solid. The definitions and their usage appears to be having some growing pains, okay? Like I said, you know, I showed you the one where it should have worked. It says, nah, nah, I don't see this. Well, that's missing code. Bottom line though is my preference is an industrial strength like using Atolic, okay? But if we go back to one of the earlier slides where I showed the relative ease of use, hey, if you're just using a sketch, you're doing a little tweaking on a sketch, it's a lot easier. There is a learning curve on using one of those. On the other hand, the learning curve is not very bad if you're using the Cube MX. It's only bad if you're not using something that will automatically generate all of the initialization code.
It's True Studio that cost, right? Isn't it?
Zero cost.
Oh, it is zero.
Zero cost.
So what are the
The
limitations
free
these
version
days?
is Pro, right?
Right. The free version has no limitation. It's just you don't get any of the extra packages. Now, at one point, okay, when I first started using them several years ago, they didn't have a code limit on. Then they put a 2K or something like that code limit on. And I said, oh shit, and I went and actually brute force put together the same environment. I mean, it's standard off the shelf Unix stuff, okay? It's, I forget what the names are now, but anyhow, it's standard off the shelf, GCC, Eclipse, what have you, okay? All right. And if you set up the Eclipse GCC properly, it will automatically generate the necessary make files, etc. Okay, it's a pain, but hey, you know, I did that. Then about a year or two ago, another group came out and started the STM code for some. Anyhow, another group essentially put together the same environment, okay, and started providing it for free. So Atolic said, oh shit. So they took their code limit off, okay? Now, the thing that you have to do with Atolic is, yes, they have a 5-second ad and all when they first up. You gotta sit through the ad for 5 seconds and what have you, and or go off and do something else while it does and say go away and use it. So they keep trying to upgrade you.
Do they keep nagging you? They used to keep nagging you.
Well, every time you bring it up, they'll nag.
Just when you first started. Well, in the old days, it used to nag you all the time.
It may. I just
I know
haven't.
this is like 10 years ago. I can't.
It may. If I haven't been in long enough
Well, but okay,
recently
so it's not
to
like-
see it
Hey,
do
Dave,
that.
We gotta,
Get out
we
of
gotta
here.
wrap it up and get out of here.
Okay.
There's another group behind us.
Anyhow, so the upshot of it is that, you know, there's the conclusion.
I guess if that, you know, the quadrature encoder is not working, that thing's probably fast enough, you could just do it, you know, if the interrupts were working, you could probably just use 2 interrupts, 2 pins, and
Well, yeah, you can do that.
Well,
But
we only
see,
need to know when you-
no, the point is that I showed you that it does work, okay?
So as long as you periodically check the
Yeah.
count at
Right.
some reasonable amount of time.
Yeah.
Based on,
I mean,
you say you could do a full wrap or what, beyond a wrap, and it would be
well,
okay.
no,
Up to
it's a half wrap,
Half wrap, okay.
okay? In other words, after a half wrap, then it's confused, okay?
Right.
But as long as it's not more than a half wrap's worth,
Plus or minus 32K, right?
right, plus or minus 32K, you're in good shape, okay?
Okay, so that's where you came up with that. It didn't matter because you're gonna periodically sum it. And when
Exactly.
you read it, it's gonna re-zero.
Exactly.
Okay.
Well, no, you don't re-zero it, because if you re-zero, you might miss something while
Oh, okay.
you're re-zeroing it, okay?
Okay.
You read it and do a difference between that and the previous reading,
Okay, got it.
okay? And that always gives you the proper
Right.
difference, either positive or negative, depending upon which way it went.
Okay, there's the secret.
Yep.
The secret recipe.